Let's start our journey into the realm of pop culture with a franchise that has been attracting fans for the last 50 years. A generation of Star Trek enthusiasts grew up watching Star Trek, the original series, which first aired in 1966. A lot has changed in the time since Captain Kirk fought a Gorn by hand in the original series. Star Trek isn't merely science fiction, but is also known to challenge inequalities in society. But Star Trek is known for single-handedly inspiring a generation of scientists and engineers whose work saw human exploration of the moon and permanent laboratories in space. My favorite Star Trek movie rebooted the franchise in 2009 with an epic space adventure with the tagline, "The Future Begins." The story begins following James Kirk's exploits as a cadet in Starfleet Academy, but an attack on the Vulcan homeworld forces the cadets to become crew of the newly commissioned USS Enterprise. Without spoiling too much of the movie, the writers of the film employed a strange form of fictional matter, called red matter, which appears to create black holes that can consume entire planets. In the movie, the Vulcan homeworld has been attacked, and the planet's surface collapses inwards. Although visually impressive, Star Trek gets a lot of the black hole physics wrong. For one, the audience is meant to understand that red matter black holes are traversable. Unfortunately, traversable wormholes are merely a theory, and would require a super advanced civilization and a number of notable scientific discoveries to permit travel. In fact, travel through a wormhole, if possible, would likely expose travelers to a serious dose of radiation, making the journey fatal to squishy humans like me. On the other hand, Star Trek explores some very interesting physics of black holes, specifically how a spacecraft might escape if it becomes trapped within the gravitational pull of a black hole. In one scene, the Enterprise is at maximum thrust and is still being accelerated towards the black hole. In order to save the crew, the chief engineer Scotty suggests that the last option is to eject the warp core and ride the shockwave from the explosion to safety. At best, it explores interesting science fiction concepts. At its worst, it makes some small, maybe forgivable errors in scientific judgment for the sake of entertainment.
I enjoy watching Star Trek and Doctor Who, but often the treatment of science in these shows doesn't satisfy my sense of scientific consistency. One movie that did satisfy me was the 2014 movie Interstellar, which presents the science of black holes as accurately as possible. There is still black hole physics that is unknown, like what happens when you cross an event horizon, so the movie makers do engage in some speculation about what happens inside a black hole. The black hole in Interstellar is a supermassive black hole named Gargantua. 2 planets are in orbit around the black hole at a safe distance, which is a reasonable possibility, even though in the TV show Doctor Who they claim that planets orbiting black holes are impossible. It is important to the plot of Interstellar that Gargantua is a supermassive black hole, since the strength of the tidal forces that could spaghettify an astronaut is weaker for more massive black holes. Although Gargantua causes enormous tides on Miller's planet, the planet that orbits closest to Gargantua, the tidal forces aren't strong enough to destroy the planet or the characters on the surface. Another cool bit of science that Interstellar gets right are the extreme time differences between Miller's planet and the spaceship that orbits farther away from the black hole. When 1 hour passes on the planet, 7 years pass for the astronauts far from the black hole. For me, the most exciting part of the movie is the view of the black hole and the disk of material flowing around it. This view of the black hole incorporates most of the science of how light travels on curved paths around regions with gargantuan gravity. The black hole Gargantua is extremely far away from us. But luckily, the writers included a wormhole that allows a quick shortcut through space between Saturn and Gargantua. Black holes exist, but wormholes probably don't, so this part is science fiction. In the movie, they speculate that the wormhole was constructed by aliens. I don't know how to construct a wormhole, but then I'm not an alien. I won't spoil the ending of the movie for you. However, I'll just let you know that there is a trip into the black hole. What happens when they enter the event horizon is pure speculation, but who knows? Maybe the screenwriters are correct.
In 1977, George Lucas presented his creation, Star Wars: A New Hope, to the world. It was packed with brand new special effects like fast-paced space battles and spectacular lightsaber duels. Sadly, Star Wars didn't include anything that we would really consider a black hole, unless you include the insatiably hungry Sarlacc. So we don't have much material from the Star Wars universe. Fortunately, though, Disney was aware of the success of Star Wars, and in 1979 decided to fund their own space opera called The Black Hole. The Black Hole was the biggest production in Disney's history, with $20 million spent on the budget, allowing them to create incredible visual effects. In the movie, the crew of the spacecraft Palomino approaches a black hole on a scientific mission, only to discover another ship in orbit around it, the Cygnus, a long-lost vessel. The crew of the Palomino must assess the dangers around the black hole and decide whether or not to mount a rescue mission. Disney's The Black Hole was one of the first works of modern filmmaking that attempted to recreate the environment around a black hole. Since we still don't have pictures of black holes, the filmmakers relied on scientists of the day to tell them what it might look like. Have a look at this scene from the bridge of the Cygnus. A stark, starry background is punctuated with a tear in the fabric of space-time. At the end of the 1970s, this was the picture of a black hole. In order to make such a convincing picture, the filmmakers relied on 20 years of work from scientists like Roy Kerr, Roger Penrose, Werner Israel, and Stephen Hawking, whose names come up a lot in this course. They had been working out models of how black holes behave and just what they might look like. In addition, the nearby black hole, Cygnus X1, which had then only been recently confirmed, became the namesake of the ship in the movie. The black hole did a lot of things correctly that other movies failed to do, like an accurate representation of an accretion disk, for the time, and accounting for the time dilation effects around the black hole. However, in the film, the crew of the Palomino descend past the event horizon, where their interpretation of the interior is almost certainly false. Instead of space-bending physics, as the Cygnus descends into the black hole, it becomes a fiery realm like a portrayal of Dante's Inferno. In reality, crossing the event horizon has dozens of dangers that would likely harm human explorers. A lot has changed in the 40 years since Disney released The Black Hole, especially related to black hole physics. We now know the strength of gravitational waves produced by merging black holes, and scientists are still developing theories to explain what the interiors of black holes might look like. This film introduces some of the interesting ideas about falling into a black hole, but there is one thing that I can tell you that none of these movies can. No one can tell you for certain what happens when you cross a black hole's event horizon.